If you have assigned syllabus for me, I need that last page only, and it'll go in this metal bin that's on the back table, not on my desk, on the back table right there. So today we did lesson 3, representing exponential growth. And by the end of it, you should have been able to make connections between an equation and a graph that represents exponential growth, and to be able to write and interpret an equation that represents exponential growth. So today, I don't know, some algebra teachers sometimes do things differently, but a lot of us had a quiz as well to do in the same hour. So it's not a huge deal that the lesson wasn't completed fully, but I know like the end probably felt a little bit rushed, and it was more towards the end of it that was a bit more important. So really quick before I go like back to the objective, the task today is the lesson 3 puzzle piece. If you are from my 3rd hour class, I think you have the information you need to start it. Okay, if you are not in my 3rd hour class, I want you to take out the note sheet from algebra if you already had it today. I'll show you what it looks like. Okay, so it's the one that has this at the top. Now, if you have not had algebra today at all, then raise your hand and keep it up until I give you it. But unless you have missed printing, then you should all have this paper, unless you also didn't have algebra. Okay, anyone else not have algebra yet today? Okay. If you are from my 3rd hour class, I still need you to be quiet while I help the rest of the class. Okay? Because in my 3rd hour, I feel like I got to the part we needed to and explained it very well. In my 1st hour, I made a mistake. And then also, I just can't be everywhere at once. So if you are in a different algebra teacher's class, just pay attention to the part that I'm going to put on the screen. So on the note sheet from today, the 5.03, look at the back of it that says multiplying microbes. So just make sure we're all on the same page, because again, today was felt a little bit rushed because of the quiz also being in the same hour. I'll make sure we understand. So for this example, in biology lab A, 500 bacteria reproduce by splitting. Every hour on the hour, each bacterium splits into 2 bacteria. So is the bacteria growing or decreasing? So if each cell is splitting into 2, should I expect more as we go on or less? More, so it's growing, which makes sense because this whole lesson is called representing exponential growth. So if we started with 500, how much should I have after 1 hour? 1,000. And then if they all split again, how much should I have after 2 hours? No. 2,000. They're all going to split into 2 after an hour. And then after another hour, how many will there be? 4,000. And then this is where I made a mistake in period 1. How many will there be in 6 hours? So you might think 8,000 because basically each time we're going down, it's doubling. But look at how the graph like or the table skips some numbers. So that was the mistake that I made earlier, is I didn't see that it skipped. That it went going up by 1 and then all of a sudden it went up by 3. So those of you that said there'd be 8,000, that's true for hour 4. All right, so in hour 4, there'd be 8,000. In another hour, you double that, there'd be 16,000. And then double that again, that would give you 32,000 in hour 6. So the right answer for that part of the table is 32,000, not 8,000. So that's where I mentioned yesterday on one of the tables, like they'll try to trick you sometimes. You just gotta read it carefully. But then it says T for hour T. And that always trips students up, like they can do the math up to a certain point, and then once that we start making it a variable, for some reason that like blows their mind. You have to see like the math that you did. Each time that we added an hour, how is it changing? Like what math did we do to go from 1,000 to 2,000? We were doubling it, so we were timesing it by 2. And then even to go from, say like, hour 3 to hour 6, we had to times it by 2, times it by 2 again, and times it by 2 again. Like we just kept doing that each time. So if you were making it on your own, you might understand that like 2 times 2 times 2 times 2 times 2, you can shorten with an exponent. So like this part, I could imagine some students getting, if I gave them more time today, that some students would figure out this part. But then you also have to remember, we started with 500. So in order for it to give you for this specific situation, for any hour that we're trying to examine, you have to also times it by what you started with. Okay? Now, if that's like hard to figure out, like I get it. That brings us to this part where we kind of show you the exponential growth formulas. So if you don't have this written down, write it down. There's 2 different ways you could represent it. I feel like the more standard way is what I have highlighted. It's y equals a times b to the x. So just like how you guys can tell me that slope intercept form, like linear is y equals mx plus b, I need you guys to be able to tell me exponentials are y equals a times b to the x. Like you just gotta like know that one, like you know y equals mx plus b. Because you do this in geometry and algebra 3-4. I know that for sure because I've tutored kids for both of those classes here, and those always come up. So y equals a times b to the x is for exponential function, where a stands for initial amount, so whatever you started with. This one we started with 500. B is your common factor. So that's like what you had to multiply by each time to get to the next number. So like if it was doubling, like we said it was times 2, times 2, times 2. My common factor is 2. And then X would be your input. So usually it's time of some sort. Y would be your output, obviously, but yeah. All right, now you might be wondering why I also showed you another equation, and that's because this one will help you a bit more, I think, with your homework. And it's the y equals a parentheses 1 plus r, close the parentheses to the t power, where a is initial amount, in the parentheses would normally be like your B, but if they give you a percentage, because sometimes it's not doubling or tripling or whatever, it's adding 3% each year or something like that. Then you will do the 1 plus R, where R is your growth rate as a decimal. So like, what's 25% as a decimal? Sorry, one more time, it's good, it'd be 0.25. What would 8% be as a decimal? 0.08. So if you don't know how to do that conversion, percents to decimals, basically divided by 100%. You get the equivalent decimal. The 1 is kind of like 100% in a way. So 1 plus whatever it's increasing by. And then to the t power, which is time. And like x is usually time. So that second one will help you more of it with your homework, because it'll say percentages. So that's that second one you use it as a percent. The top one you use when it's like times 2 or tripling, quadrupling, something like that. Okay, questions on that? So let's do like this part of it too. It's really quick. So slightly different situation. In biology lab B, a population of single cell parasites also reproduce hourly. An equation that gives a number of parasites P after T hours is right here. I'll box it up for you. So P equals 100 times 3 to the T power. And we're explaining what the 100 and what the 3 represents. Think about it yourself. So in the biology lab B, what is the 100 referring to? Okay. So it's my starting amount of bacteria. Or it looks like parasites, but same difference. That's my starting amount of single cell parasites. And then what is the 3 representing? Not the hours, yes, that it's tripling each time. This is my common factor. This is what I would be timesing by to get to the next number. So like in hour 1, there would be 300. In hour 3, I'd have to do 300 times 3. Stuff like that. So yeah, this happens to be tripling. Okay, so that I feel like even if you didn't have the lesson yet, now you have enough to be able to attempt the practice. Next week sometime we'll see like, okay, is that a good setup to try to practice before you have the lesson, or do we need to do more like small group first and things like that? So we'll see. So everyone now, if you haven't started the practice yet, for some reason you have started. Goal is 80% or higher. So anyone have a question? Okay, I'm gonna go make sure they're all enabled. So give me some time. So okay. So if you also needed help with this one, yours could be shuffled or it might not be, but it's the one that's about in 1985. There were 285 cell phone subscribers in Mayville. The number of subscribers increased by 75% each year after 1985. How many subscribers were there in 2008? So you had 2 formulas today. One that is better if it says things like doubling, tripling, things like that. The other one, when it's a percentage. So I'm going to use the one that has the percentage part. All right, Y would just be your output, it would be your answer. A is for initial amount. So what's my initial amount in this one? 285. That's gonna be times in parentheses 1 plus my growth rate as a decimal. So it's increasing by 75%. What's 75% as a decimal? 0.75. And then to the T power, so that's time, and it's saying that it says that the number of subscribers increased by 75% per year after 1985, and then it wants to know in 2008, how many were there? So what's that time difference? How many years? $22 years? Okay. Okay, good. That's just the math you did though, right? Yeah. Okay. So 23 is what the exponent would have to be. Okay, I'm gonna put in the calculator right now, so we'll compare. If you're not working on this problem or in my little small group of this problem, then you are quiet and working on the practice yourself, okay? So I'm gonna have to put this in the calculator. At this point, there's like no way you could try to do these by hand anymore. I don't think it would be wise to try and like chunk it. Just let the calculator do the order of operations for you. So it was my initial amount times 1 plus my growth rate as a decimal. Those parentheses, and then to the exponent of 23, because that's how many years passed from 1985 to 2008. Well, the question of if you need to round it depends on what we're talking about. Are we talking about like money? Is my answer representing money at all? Is it representing things that can't be decimals, like people? Yeah, subscribers would be people. So I can't have a decimal. And here's where it could be like a bit confusing. So just don't even look at the decimal, to be honest. If I'm doing an exponential growth function and using it to estimate stuff, even if this decimal was like 0.9, I'm still gonna have my answer be like where it ends in an 8. Even if my decimal was like 0.9 or something like that, I wouldn't round up because the data only supports this amount. So don't put the decimal part. You can't have 0.273 of a person. Only for the ones that are talking about like people or like things that can't be decimals. Like if they were talking about fish, can't have a decimal of a fish. So, but if it was like money, yeah, you'd want 2 decimals if it was money. If it was a money. Okay. Okay, hold please, everyone. This one, let's make sure the answer key is correct. And then also the question came like, do we put commas? It shouldn't mark you off right now if it does. Or if you don't put a comma. But sometimes it does, and then you just need to tell me and I'll update the key. 845988. Okay, so if you type it in like this, it'll mark it right. If you put the commas like that, that's how you put commas in for big numbers. Then it'll also still be correct. Okay, and then so Jay, you were saying about number 7. So yeah, in number 7, where it's talking about people, whatever decimal it is, it really doesn't matter. Don't include any decimal. Don't even round it, even if you would normally round up to the whole number. Like it only supports what's before the decimal point, if that makes sense. Okay, other questions at all from this practice or really any of the unit 5 stuff, Tatiana? Well, what is your answer talking about? So if it's money, how many decimal spots does money normally have? So you'll round to 2 spots. Yes, to 2 decimal spots. Yeah, the hundredth. Okay, other questions from Jaya? 4. Okay, so the matching one. So for those of you that had algebra, hopefully it makes sense already. For those of you that didn't have it yet today, that paper that I gave you, the front of it has exponent rules. Okay, what is your? Okay, so not a question on this. Hang on. How does it start again? Okay. Okay, this was the one that we were asking about. So the exponential appreciation basically just means it's growing is what appreciation means. Looks like this, y equals a times b to the x. A stands for what class? Initial amount, which of these phrases would be a synonym for initial amount? So what's another synonym? Starting amount, y-intercept, what else? The first number in the sequence. So A is your original value. B is my what in this one? It is not. 1 plus the exponential factor. So you remember how I gave you this equation and this one? Where B is, because B is what is attached to the exponent. This is now attached to the exponent. So another way to talk about B is 1 plus the exponential factor. If it was doubling, then it's 1 plus 1, which is 2. So it's like, use both. Y stands for what? The value after an amount of time, like your output. And X is usually time anyway. Like when you graph something on the X-axis is usually time. So there you go. Questions on this one? Questions on any others from any unit 5 stuff? It doesn't just have to be this practice. Yes. Questions? Okay. So the cost of tuition at a college is $12,000 and increases at a rate of 6% each year. Something in exponential function to find the tuition cost after 4 years. So because it's increasing at a rate of 6%, I'm going to want to use this one, not the a times b to the x. And just translate it to plug into the formula. So what's going to be my a in this one? $12,000, my initial amount. So put the 12,000 there. And then in parentheses, so just following the formula, it's gonna be 1 plus whatever R is. So 6% as a decimal is good. And T is the time frame that we're looking at, which is 4. This, except for like the Y equals, this you're gonna put in your calculator all at once. not like your iPhone calculator that only lets you put things in one at a time. Put that all in at once. Let me do that, because we can talk about what to round to. But it's 12,000 parentheses 1 plus my growth rate. Close parentheses to the 4th power. And see what your answer is representing. What's my answer representing? Money, it's cost of tuition. So I should have 2 decimal places. Anytime you're rounding, so like I'm rounding to 2 decimal spots right here. You look to the right. Depending on what the number is to the right of it will tell you what to round to. So if it's 0 to 4, it stays. If it's 5 through 9, you round up. Since to the right of where I'm rounding is a 3, I'm gonna leave that 2 a 2. So then what you put in the box is this. And it should mark it right whether or not you put a comma in between here. Don't put another dollar sign. Like if there's a dollar sign outside the text box, don't put another one. Questions on this one? Any others? Okay, let me put that in my calculator, don't switch it, just in case. Cause I don't recall, well, actually, yeah, we look at it. So this one, when you round it, the one you're at. Wait, was it this one right now? Or this one? Okay, well, here's the problem with this one that I have. This is what I have. When you go to round it to the 2 decimal spots, you look to the right, since that's a 5, your answer should be 0.04. Okay, there's that. For this one was talking about T. Oh, no, it didn't. Okay, so 440, and like normally you would round up if we were rounding to the whole number, but because like there's no data to support a full person, it's only 0.75 of a person, you just leave it as 440. Okay, good. Any other questions? Number 3. Okay, can you guys not pack up just yet? You'll have time. This will probably be our last one. So the number of student athletes at a local high school is 300 and it's increasing at a rate of 8% each year. Use an exponential function to find the number of student athletes after 5 years. So because it has that percentage, I'm going to use this formula out of the 2 that I gave you. What's my A going to be? 300, because that's what I'm starting with. What's my growth rate? So it's growing at a rate of 8%. Make sure you put it as a decimal in your formula. And the time frame is. And when you put that in your calculator, for making this. Okay, so you see this answer? What is this supposed to represent? So when it represents people, don't even look at the decimal. Don't round to the whole number, because it doesn't support a full person. This data, if it's growing by that rate, doesn't support a full person. So you can't say 441, even though you normally round to that. It's just 440, that's it. Make sense? Yeah, that's the only time, like, if it's people, you just don't even look at the decimal at all. Unless it tells you around. All right, questions at all? Okay, good. So if you didn't get 80% or higher in here, that's still your task. Make sure you do that at some point.